Good day everyone, I'm Riza and I will be your tutor about binomial and Poisson binomial. Theorem 20. Let a random variable x have a Poisson distribution with parameter lambda, then for fixed a less than b. We have the probability of x minus lambda all over square root of lambda greater than a less than b. So we are going to eliminate the denominator. So we are going to multiply it by square root of lambda. So we have the probability of x minus lambda greater than a square root of lambda less than b square root of lambda. Overall, we have the probability of x is greater than 2 lambda plus a square root of lambda less than lambda plus b square root of lambda. Using the normal distribution formula, we have phi of x is equal to the integral of 1 all over square root of 2 pi sigma times e to the power of negative x minus mu quantity squared all over 2 sigma squared evaluated from lambda plus a square root of lambda to lambda plus b square root of lambda dx. So we let y is equal to x minus mu over sigma. We have the integral of 1 all over 2 square root of 2 pi sigma times e to the power of negative 1/2 times x minus mu all over sigma quantity squared. So we have phi of x is equal to 1 over square root of 2 pi sigma times e to the power of negative 1/2 y squared. We have phi of y is equal to the integral of phi of x evaluated from a to b dx. So we integrate it. We have phi of y integrated from a to b. So let y is equal to x minus mu all over sigma. We have phi times x minus mu sigma minus phi times x minus mu sigma. So this is our b and this is our a. We have phi times lambda plus b square root of lambda minus mu all over sigma minus phi times lambda plus a square root of lambda minus mu all over sigma. So we have phi lambda plus phi square root of times the quantity of b square root of lambda minus phi mu minus phi lambda minus phi times the quantity of a square root of lambda plus phi mu. So we have phi times b square root of lambda all over sigma minus phi times a square root of lambda all over sigma. So we're going to simplify it. So we have phi of b minus phi of a. So this is our answer. Theorem 21. Let a random variable x have a binomial distribution with parameters n and p. Then for fixed a less than b. Probability of x minus np all over square root of npq greater than or equal to a less than or equal to b. So like what we did in Theorem 20, we are going to multiply it with square root of npq. So we have the probability of x greater than or equal to a square root of npq less than or equal to b square root of npq. So we have x greater than or equal to np plus a square root of npq less than or equal np plus b square root of npq. So this is our phi of b and our minus phi of a. So using our normal distribution formula, we have f of x is equal to 1 all over square root of 2 pi sigma times e to the power of negative x minus mu quantity squared all over 2 sigma squared. So we have phi of x is equal to the integral of 1 over square root of 2 pi sigma times e to the power of negative x minus mu quantity squared all over 2 sigma squared evaluated from a to b dx. So we have the integral of 1 over square root of 2 pi sigma times e to the power of negative 1/2 y squared evaluated from a to b dx. Then we have phi of x is equal to 1 over square root of 2 pi sigma times e to the power of negative 1/2 times y squared. We have the integral of phi of x evaluated from a to b dx. So we integrate it. We have phi of y integrated from a to b equals to the phi of b minus phi of a. So this is our final answer. Thank you for listening. For more videos, just visit our Facebook page, CMU Statistics Class. Thank you.